Hi, in this topic, we'll look at NAT instances. So I would request if before going through this topic, if you can also browse through my previous video on VPCs and creating custom VPCs, that will be helpful in understanding the NAT concept. Let's quickly look at what is VPC. So VPC is a virtual private cloud. So this green boundary, if you see, this is the VPC. And inside this VPC, I have a public subnet and I have a private subnet. Within the private subnet, I have an EC2 instance, and within the public subnet, I have another EC2 instance. How are these two instances different than each from each other? Why is one called a NAT instance? It is because the EC2 instance, which is on the public subnet, it has the source destination check set, which makes it a NAT instance. Let's look at a screenshot where you can understand how the source destination flag is checked. So this is a screen where you have the NAT instance. This is a similar simple EC2 instance, but you go to the networking properties and change the source destination flag here. So in order to change the flag, you get this screen where the status is enabled. And if you want to disable it, then you click yes disable. Otherwise, you have to keep it enabled. So for the NAT instances, you have to keep this enabled. This is the key. Now let's understand how is NAT instance different than the internet gateway. You saw internet gateway, that is Amazon managed. NAT instance is something which you have to manage it. So the difficulty here, the flip side of NAT instances is that you have to create inbound and outbound rules inside the security groups, as well as you have to create entries in the route table. In the internet gateways, you saw that you just created entries in the route tables, and you don't have to worry about the bandwidth and etc. Here you have to worry about the bandwidth. Your bandwidth is only as good as the this instance type. If you have a higher instance type, your bandwidth will be more. If you have a lower instance type, then your speed and bandwidth will be less. Now let's look at the security group settings. So for the public instance, which is NAT instance, for this instance, what you have to do is you already have SSH, and SSH is doing this is 0.0. This is what is open to the web. But you have to add two more types, one for HTTP and the other for HTTPS. Okay, so if you see these two IPs, these are private AWS IPs. And why you want to do that, why you want to make an entry here in the public instance? It is because your instances, your private instances, like you saw in the previous diagram, your private instances can talk to the public instances. This is a NAT instance, and in order for them to do that, you want to allow the HTTP from those VPCs. If you don't allow it, then it is unreachable. Now let's quickly look at on the private instance what security group setting that you have to do. This is not open to public, so you will have your internal custom IP, and you should be able to do SSH from within the VPC. So this is for your private SSH within the AWS network. It cannot talk to the internet without routing it through the NAT gateway instances or NAT instances. Now let's look into the route table entries that is needed for this. So in the route table, you have to mention that anything that is other than this local IP, it has to be routed to the NAT instance. This is the instance that you have created in the previous diagram. I'll show you the diagram. So this is the diagram. This is the EC2 NAT instance, and for this EC2 NAT instance, you have created an entry in the route table so that any other IPs, it should hit this NAT instance. So just to summarize, when you have to set a NAT instance, what you do is you create a EC2 instance in your private subnet, you create a EC2 instance in your public subnet, and you enable the source destination flag to make it a NAT instance. Then you have to do security group settings both at this NAT instance as well as at the EC2 level. And then you have to make an entry in a route table. This is a route table where you have to uh, uh, ensure that the routing and the target happens to be the NAT instance. So this is in a nutshell, this is how NAT instance works. Now let us look at what are the disadvantages of the NAT instance. There are some key disadvantages. The first is a lot of rules has to be added in the security group. You just saw in the security group. I'll quickly show you the security group. This is the public instance security group where you had to add these rules. So these are your inbound and outbound rules. And then you also went to the public private instance and you added these rules. So these are your security group settings. This is your security group settings. So you have to add these many security group rules If you go through my last video on internet gateways, if you see, there is no security group rules that we added. We made entries to the route tables. Now in this case, what is happening is, you have to add security group rules as well as the route table entries. Otherwise, this will not work. And this is an additional step that I would say this is not a key differentiator. It Because adding those security group rules, additional rules, does not take a lot of time, but then a lot of configuration effort needs to be gone if you have a bigger setup where you have a fleet of EC2 instances. uh, the next thing is, in order to make it highly available, in order to make the NAT instances highly available, you need to do a multi-AZ deployment. This goes true with anything, even with internet gateways. In order to make the internet gateway highly available, you have to do a multi-AZ deployment of the internet gateway. So in this case, what will happen, let's quickly go to the diagram. So this is one VPC. If your NAT instances fails, your EC2 instances on the private subnet will not be able to talk to the internet. Okay, and that's why you want to create a multi-AZ deployment for this orange EC2 instance. So if it is there on three instances, even if one fails, it can be routed to the other AZ instances, and that way your NAT instances will always keep providing you access to the internet. Now, one more thing that is very important, and it's a key differentiator. If you compare with the internet gateway is AWS managed, and the bandwidth and etc. You get pretty high bandwidths. Here you are in control, so you have to establish auto scaling group so that you can increase your bandwidth. So let's quickly look at the diagram to explain it more. Now, for demo purposes, if you start creating with the T2 micro, obviously your internet bandwidth will be pretty less. But if you keep increasing that, that is one way of doing it. Or you can do a horizontal scaling of these instances where you set up a auto scaling group. And the moment you want more bandwidth and there are more requests coming in, this can auto span and create multiple instances. And that way you can provide higher bandwidth. Okay, that's it for the NAT instances. This is all we have to cover from an exam perspective, but it is very important to understand. At least we will get one questions on the NAT instance. The next topic we'll cover is the NAT gateways.